when you're home, I think it's super hard to see that. If I'm videoing, I don't know if you've seen that. It seems super bright when I've gone back to look at it. I am trying to do this, but more using slides. So did you see that slide I had?
Yeah.
Okay. You know, when you're home and you're maybe watching the video, if you could, I don't know, is there a way? Maybe watch a video on your phone and then have the slides on your Chromebook so you can kind of maybe follow along or something? Because you can't split screen your Chromebook, can you?
Yeah,
You can? Okay, that would be a good option because I'm going to try to kind of go along with that. I'm just going to take attendance super quick. I want to get going at this like right away because there's a lot of good stuff today, and I'm hoping maybe we can even finish with a little activity at the end that I was going to do with class tomorrow. If we don't get to that, that means you're going to have to do the activity at home, okay? And so I prefer to do it with you. You present. Okay, now, yesterday the whole purpose of it was to just introduce what a limit means and look at it graphically and try to make some determination and then kind of look at the notation. Yes? I'm sorry, what?
You just literally type in MC calculator and you just click the button.
Yeah, go through 9th and 11th grade, obviously. Okay, before I do that, a couple housekeeping things. On Wednesdays, tomorrow, I'm going to assign the take-home test.
MCA.
Whoops. Okay. I'm going to assign the take-home test. All right. And you're going to work with study buddies. You guys hearing that? You got your study buddy groups?
They're like 3 people, right?
3 to 4.
Okay.
Okay. I think there's only one group with 3. I just try to make it simple. Okay. So now here's the deal. I'll just post the test online, so those of you that are home on Wednesday, you could look at it. But when you come to class on Thursday, I can give you a hard copy of it. Okay.
Not working.
It's not working. It worked for me though.
Error.
I don't-
Operating system.
Your
version.
Chromebook settings need to be updated.
Just go
Try going to Chromebook settings and update them. Try doing it real quick. Do you not know how to do that? Does anybody know how that can
Ours
help
are
her?
just the old ones.
I don't want to like take class time right now to go.
Can I have on my phone?
Yeah, if you've got a calculator on your phone, do that. Do you have a graphing calculator on your phone?
I could look up the same website, couldn't I?
You could try it, see if it works.
There's definitely apps that are good.
Good idea. Okay. All right. Well, okay. Let me get back to this. Okay. Take-home test. I'm assigning Wednesday. You're going to work in your study buddy groups. They're going to be due. If you're A group, I want you to hand it in physically on Monday. If you're a B group, I want you to hand it in physically on Tuesday. And if you're those distance learners, you're going to electronically submit it to me. So I'm going to collect a test from everybody, but I'm only grading one of your groups. So you're going to identify which of the person in your group has the best handwriting. That's the test that's being graded, but everybody's test should be the same because you're working collaboratively and agreeing on the answer and the solution. Is that clear?
Yep.
Okay, good. All right, so yesterday you guys missed a little bit just about limits, and I shared a quick story about like Stoic and what he talked about with his story of limits. And he had this story when he was a younger kid. He had a younger brother and a neighbor friend, and they would do these challenges every day. And they'd get on their bikes with a banana seat. Did you guys ever have a banana seat bicycle? Super cool in my day, and I'm kind of in that Stoic day too. But they would open their garage door, and they would come flying up on their bike, and they would try to swing their bike around and see who could get the closest to the back wall of the garage without hitting it, right? And they would do that for hours. Well, one day his little brother just swung his bike in, and he was within 2 inches of that wall, the best anybody had ever done, without hitting the wall. And Stoic's like, I'm not going to let him beat me. So he got on his bike, and he's flinging around, and he comes, and then the brakes don't work, and guess what happens? He smacks right into that wall and puts a big dent into the wall with his head, okay? The garage wall was the limit, right? The idea of a limit. You can get super, super close and approach, and you don't even have to touch that limit, okay? So That's one thing I want you to consider. The other thing I want you to consider when you look at a graph, think of it as roads coming in, maybe from the left and the right. They're getting closer and closer and closer to that point. There might not even be a point there, but as they get closer and closer and closer, they're getting to that value, and that's the limit. So you could come in from one side of this road and another side of the road, and the house might be empty. There might be a hole right there, but the limit is still that value. It's that Y value, okay? So what we're going to do to begin with, we're going to look at tables today and a few other things, but I want us to just take a minute to see if we can calculate some of these limits, okay? So let's look. F of 6, let's make a quick table. What would F of 6 be, folks? F of 6, can you see it?
5.
5, I like that. F of 6 is 5. So he went up and he actually looked at what's the value. Oh no, it isn't 5, sorry.
2.
It's 2. This is what, yeah, right there, that point, it should have been 2, right? There's a hole at 5, that's not what we want. So F of 6, the value of the function at x equals 6 is 2. What's the limit as we approach?
Why is it 2? Why isn't it not 5?
Yeah.
Just thought it was a whole swimming
There's a
pool.
hole at that ordered pair, 6, 5. This is what's, if x is 6, y is 2.
What does the hole have to do again?
The hole, that's not a point on the graph. There's an open space there. There's not a point. There's not an actual value 6, 5. There's a hole.
Oh,
This
it's just
is-
saying that the
If
line
you're-
is on 6, 5?
I'm sorry,
It's
what?
just saying the line's on 6, 5?
It kind of, it's approaching 6, 5, but right there you're gonna have a little hole. There's no value right there. You got an open space, and then the function continues after that. We're gonna get into the algebra of holes later, but just recognize where you filled in the dot, that's the actual value for the
Okay, so
function.
look at the filled in dots.
Absolutely.
Okay.
These are just all filled in dots, right? When it's solid like that, they're all little filled in dots, right?
Mm-hmm.
Okay, so then, do you guys know what's that notation mean with the 6 minus?
Negative?
No, it had the negative in front, so this is super important. This is what we should have got yesterday.
To a positive, right?
Nope. Did you guys watch the slide?
Uh-uh.
Did you watch the AP videos?
I watched the AP videos.
Okay, you guys, if I give you an assignment at home, it's super important, especially this class. And you gotta do it, okay? So, because otherwise you will just crash and burn.
From left to right. That's what it was.
Nice! This means it's coming in from the left. So what's the limit
Oh, boy, Paul.
as the graph comes in from the left of x equals 6? What are we approaching, folks?
6, 5.
We're approaching 5. Okay, so the limit of this graph, as x approaches 6 from the left, is 5. What's the limit, the next one over? What does it mean if I have a 6 plus there? You're coming in from the right. Follow that road in from the right. As I get closer and closer, what is my y value getting close to? 5. Good. So then what would we say this limit is?
6.
As x approaches 6,
2.
f of x approaches what?
5.
5. Here's a situation where you got a road coming in from the right, you got a road coming in from the left, and they go to this house. Think of it like a home. Nobody's in that house, but that house is there. They're getting super close to 5. They don't have to touch 5. Okay? So this is a scenario, though, even though the function doesn't equal 5, the limit is 5. Okay? So when you got that hole, look at where they're getting super, super close to. Okay? Let's do this one. What's f of negative 4?
Where's the line then for x score 6, 2? How does it get to 5?
Let me get a pointer out here, sir. Where is my pointer? I gotta get something so I can show you what I'm trying to say. Okay. So, when you're trying to find a limit at a given point, okay, when it's approaching, x is approaching 6, that means as I get closer and closer to x equals 6, my graph gets closer and closer to y equals 5. It's getting closer and closer to 5. My limit as x approaches 6 is 5. Because right over here, that value is 5.
But why is it that point instead of like 6, 4?
Well, because my graph isn't coming up. So 4 would be like right here. Do I
Okay.
even have it, my graph going near that point at all?
No, but you said 6, 5 isn't a point on the graph.
It's not a point on the graph, but as I follow this and I get super, super close, it approaches 5. It's getting really, really close to 5 here, and it's getting really, really close to 5 there. It doesn't need to be a point on the graph, but it can be a limit. We're getting really close to it, okay? So if you have a graph where it's meeting at that spot, but you still have a hole, that value could still be a limit. Okay? You think about it for a little bit. I'm going to keep going here. What do you think f of negative 4 is? So let's look. At negative 4, do I have any closed-in value at all?
No, because it's a hole.
No, so that's a does not exist. There is no value for f of negative 4 here. So you can write DNE for does not exist all year long.
For the whole column then?
For this one would be DNE. This one we said was 2 though, right?
No, but like for the whole, that whole row.
Well, let's see. Let's see. What's the limit as x approaches 4 from the left?
Oh, from the
Follow that road. Good. It gets close to 2. So the limit from the left is 2. What's the limit from the right? 2. Right? Because as you come in from the right, you get super close to 2. So what's the limit as x approaches negative 4?
2.
2. So if the limit to the left is 2, the limit to the right is 2, the basic limit is 2. If those match, you're going to get 2.
What does it mean when it says limit two-sided?
That means I'm coming from both sides. I'm trying to meet. If I keep following this, what do I hit? Even there's a hole there, that value is 2.
It's 2.
Yeah. Okay, how about this one? What's f of 1? Look at that graph. What would you say? What is f of 1?
4.
4. That's where the darkened spot is, right?
Uh-huh.
So what is it from the left? The limit from the left?
It's 1.
No.
The y value, sir.
4.
4. The limit from the left is 4. What's the limit from the right?
It does not exist, right?
If you come in from the right, what am I getting super close to?
Negative 2.
Negative 2. So what's the limit from both sides?
Uno.
Do those roads meet?
No, does not exist.
Does not exist. If
Yeah.
your roads
Oh,
don't
it's
meet,
clicking.
folks, it's a D and E. Does not exist. This one?
Yeah.
So here's your x value as 1. So as you're coming in from the right, here are your y values. What do I get really, really close to when I come in from the right? Negative 2. Your y value is negative 2 right there. So when you're coming in from the right, if you're following this road in from the right, you're getting super close to y equals negative 2. Okay?
So Shens, I can just write it like that, limit function equals 5, like, we know.
Yeah, but you'll have to, like this is left-sided, this is right-sided. Often I'll just we're just going to look at the two-sided. Okay? I should have an equal. You know what I mean? Okay? So let's look at the next screen, because the next screen shows the answers, okay? And so this might be another thing, like if you're going through this at home, this would be a great slide to look at again. Test yourself. Can I get them? Okay, because this is an important concept that we have to be able to do. Let's keep going. I'm glad we did this. Now look at this. We didn't talk about this yesterday, and it wasn't in the slide. Let's talk about what this would mean, piecewise function. Okay, so this one here. What do we think that is? What does that mean? The limit, and I really should have f of x here. You would get in trouble if you didn't have f of x written here in the AP test. So that was my bad. I'm going to go back and fix this slide when we're done. That's super important, okay? That f of x. So what's the limit as x approaches 1 from the left? Which of these functions would I use if I'm looking at x coming in from the left? Think of a number line. Would I use function 1,
You use
2, or
function-
3?
Oh,
If x is
3.
coming in from the left.
3.
Okay, I'm hearing a lot of things. Okay, so here we got it broken up. Here's 1, and then I have something from 1 to 5, and then I have something for x greater than 5.
no, it's definitely function one.
Function 1, I'm just gonna write. These are the functions in the different branches. I
Because
should-
as it's approaching one, right? And that's why it's going, wait.
So if I'm coming in from the left, wouldn't x be less than 1?
Yeah.
Right? If you're coming in from the left on the x-axis, x is less than 1, right? So you're going to use this one. So what is the value at x equals 1? What would you put? You put 1 in there. This is just a substitution. Negative 1 plus 2
1.
is 1. So this would be a value of 1. What is it from the right? Which branch am I going to use then? Think about like this number line. If I'm coming in from the right, I know right here.
It could be, because you did the other one too.
No, because this is when x is less than 1. That's to the left.
3. No, 2 and 3.
X has to be greater than 5, so you're not even close to 1. It's got to get super close to 1, right? The only way I'm going to get super close to 1 is in this region right here. X is going to get really, really close to 1. At x equals 1, my function is 2. Okay? We can draw this graph real quick. Let's draw it. That might help. Okay, piecewise functions. When x is less than 1, so here's 1, and then I'm going to do 2, 3, 4, 5. So 1, 5, and then greater than 5. So when x is less than 1, my function is this. 2, and I got a slope of negative 1. And it's less than. So this is the graph here. Negative x plus 2, right? From 1 to 5, it equals 2. So I'm going to do a closed circle on 1 and go over to 5 and do an open circle. Constant function, right? From 2 to 5, my y value is 2 all the way across. I did a closed circle here because that's where it equals open circle there. And then 1/2 x plus 1 for values greater than 5. Okay? Well, if I plug a 5 in there, let's just do this real quick, get a point. I'm going to get 2.5 plus 1, that's 3.5, and it's an open circle, okay? And I have a slope of 1/2, so up 1 over 2, up 1 over 2, my graph looks like that. Okay? So, again, when it's coming in from the left, at x equals 1, my value is 1, right? When it comes in from the right, my value is 2. So what is from both sides? Do my roads meet?
No.
So what do we write?
Yeah.
D and E. Does not exist. Let's do this one. 5 from the left. So I'm going to be in this branch, right? If I'm coming in from the left, I'm going to be less than 5. So this picture helps, but you want to get to almost where you can look at it piecewise and kind of get it, right? If I come in from the left, what number am I getting super close to? Maybe not touching, but it's super close to. 2, right? Your y value is 2. If I come in from the right, I'll use this one. I get super close to 3.5. What's the limit from both sides? D and E. Okay? So, good practice. My cardinal rule, you gotta have f of x in here. So I look at that, I'm like, shoot, my bad. I put this in real quick last night because I wanted to make sure we covered that. So I will go back and fill that in and fix it. Okay, let's look at this table now. These are values of a function. Here's f of x. Here's my inputs, right? So look at here, from the left side, I get super, super close to 1, don't I? And on the right side, I'm getting super, super close to 1. What do you think would be a good guesstimate then for your limit? 3. We assume it's 3. There's a lot of things that could happen in between this 0.99 and this 1.001. A lot of things could happen, but looking at the table, I'm gonna make an assumption it's 3, okay? You could technically maybe even have a vertical asymptote at x equals 1, and it might be it does not exist, but we don't know that. So we're gonna assume, just by looking at the table, the function is approaching 3, okay? So looking at a table, that's a good guess. Now, let's fill this in real quick. The limit as x approaches 2 of 3x minus 2. So I'm going to fill in a table, and I'm going to get super, super close to 2 from the left. So I'll go plug in 1.9, 1.99, 1.999. Then I'm going to go from the right. Let's start at 2.1, 2.01, 2.001, okay? I was literally going to have you guys punch this in your calculator right now. Like, have one of you evaluate it for 1.9, another one for 1.99. You know what I mean? Because of time, we're not going to do that. Here's my table. These are the values. If you plug 1.9 in, you get that. 1.99, you get that. Okay? What do you think the limit is, folks? It looks like it's a 4. We can assume from that table that we're going to approach 4 because we're getting closer and closer to that y value of 4. Okay? Notice something, and this is what you're going to learn tomorrow. So you guys are home, and tomorrow's kind of a big day. You're going to look about ways to analyze them algebraically. What happens if you plug 2 in there, folks?
You get 4.
You get 4. So algebraically, if you've got a polynomial like this, you can just do a direct substitution in to find the limit. Isn't that cool? Okay, but looking at that table, can you see why we would say it's 4? Okay, good. All right, now let's look at this. What happens if you plug 1 in here, folks? You get 0 on top and you get 0 on the bottom. First of all, we got a big problem. We can never divide by 0 in math. So having a 0 in our denominator should say, whoa, we got issues. AP, Calc, in the spring, never write like it equals 0 over 0. You're going to get in trouble with that equals, okay? This is called the indeterminate form, and that tells us, hey, we got issues. I can't calculate the limit as it is right now, okay? What I want to do right now is we're all going to graph this on a graphing calculator, and we're going to examine the table and look at what happens again at 1, okay? So if you don't have a graphing calculator, you're going to watch kind of closely what we're doing here. Let me escape and get my calculator out. Online calculator. Yeah, you don't see it anymore. So it was x cubed minus 1 over x minus 1. Y equals. Alpha y equals gives you a fraction. X cubed minus 1 over x minus 1. Okay? Now, I want everybody to do this. This is a skill. We're going to learn a lot of calculator skills in here. I want you to do zoom 4. Zoom 4. What do you see happens at x equals 1, folks?
There's nothing there. There's a gap.
There's a dang hole, right? We got issues. So look at the table. At x equals 1, what does it say? Error. Okay? There's a hole. But that doesn't mean a limit doesn't exist there. As I get super, super close, what's happening? So let me go back to our thing here. View, present. That zoom 4 is going to be really important. At x equals 1, we get a hole. The table, we get an error. So what could we conclude about the graph? Well, here, let me go back to the graph real quick. A couple of things you can do on your graph. You could change your table set. So if you go to table set, and we're approaching 1, I'm going to set my table start at 0.95, and I'm going to make my delta table, what it changes by, to be 0.01. Okay? Now if you go to your table, look at here. This is kind of like those tables we just put on the board. Do you see how it's getting super close to 3 now? You see that? So playing with that table. Also, if I were to just pick, let's go back to graph and do trace, and kind of keep arrowing closer and closer and closer, I got it in decimal mode, fraction mode, but those values are gonna get super, super close to 3, okay? So looking at your graph, be super careful, use that zoom 4 to see kind of what's going on. Okay, so we're approaching 3. Now, what happens when you plug 0 in here, folks? 0 over 0. We got issues again, don't we? Right? We can't have 0 over 0. So, graph this into your graphing calculator right now. Type that in. X over the square root of x plus 1 minus 1. Okay, so your graph should look something like this. Now when you do trace again, okay, at x equals 0, I don't have my trace, but let me see what my next slide shows. Using trace and I get to x equals 0, you don't get any value there. Okay, that's going to happen if you have an error. But if you go to the table, and again, I played with my table set. And I've got values here. What's happening at x equals 0? So this is negative 0.009, where this is 0.001. What do you think it approaches when you look at your table? Look at these numbers here for your y value.
Oh.
2. At your table, you can assume that it's 2. So a limit can exist at a point even though the function does not exist at that point. You can't plug 0 into this function. You're getting an error. Okay? Now we're going to try another one. Type this into your calculator, please. I need you to do this with me if you've got a calculator. I know some of you that aren't having a calculator thing, you have a Chromebook setting issue. So you can go to the tech desk to get help, or maybe stop at my desk afterwards if we have time. Okay, now, everybody's going to type this into your graphing calculator. I'll do it real quick too, because I want to show you a few things with your graphing calculator. So x squared plus 6x plus 6. I don't want that one. Y equals x squared. I'm just going to switch this one. Was it plus 6x?
Just
Yeah,
Over x?
yeah.
Okay, so my delete. I can't let x equal 0. It's undefined for x equals 0. So when I do zoom 4, first of all, we're going to have to switch it and just see that. So I'm going to go up to my window and make my y max, let's just make it 8 so we can see that graph. There's technically a hole right there, but you can't see this. So I'm going to show you some things with your calculator. If you go to your window, no, I don't want my window. Second table set, I don't want that. Where did I do that? Zoom. I'm trying to figure out where it is. Oh, here's where I want. Go to second format, and you're going to turn your axis off. So if you have a colored calculator, you have to go down to axes down here. And I think you back arrow. Just keep going. There, I had off. You should have a spot where you can turn your axis off. Okay? So it's second format. Turn your axes off. And now when I graph it, you can see there's a little hole right there. Okay? So playing with your calculator, you can't just look at a graph and make assumptions. We gotta kind of know that. Now you're gonna want to turn your axes back on because I think it stays off. So go back down and turn it back on. Go to second format again, change it to black. Okay. So some things you need to be aware of with your calculator. Losing 10 minutes in class really impacts what I can cover, but those are important things. Okay. We'll go over them again later. Okay. We'll hit them all year long. Now, keep going. Other techniques you can do for your calculator. Okay? So one thing you can do is if you wanted to evaluate a limit using a table, you can go and change your independent to ask, and I'm going to show you what that looks like, okay? So I'm going to do x squared minus 4 over x minus 2. Now notice again, if I put 2 in, I get 0 over 0. We have issues with that. So let's look at our table. I'm going to go here, y equals, you can kind of just maybe watch with this one. So alpha y equals, I'm gonna do x squared minus 4 over x minus 2, okay? And I'm gonna go to second table set, and I'm gonna ask my independent variable, I'm gonna switch that to x. That's your x value. Okay? So now watch what happens when I go to my table. Remember, I wanna know what it's like when it gets super close to 2. You could go here and go 1.9, enter, it gives you the value. I want it to be not in, let me change my mode. I want it to be in decimal, not. Where is my, here, decimal. Decimal's better for this. Okay, so when I go to second table, you can just type in numbers. So if you needed to fill out a quick table, you can get numbers super, super close to 2. Right? And I could go 2.001 to 2.01. Those are ways that you can see, oh, as I get really close to 2, my y values are getting really close to 4. Okay? Here's another thing, folks. You're going to learn a lot about calculators, so you're lucky to be in class today because this is kind of cool stuff. You can go to alpha, home range. You can go to bars, go over to y bars, and hit enter. Now y1's in my, oh shoot, get out of here. Let me do it again. Bars, y bars, function, select y1. Now I can go and just put in like 1.9, enter. If you do second equal here, second enter, you can add another 9. Second enter, enter is equal, add another 9. So you see how I can quickly plug in values? I could try now 2.01. And at 01. Second enter, 2.001. I hit the wrong button. But there's another way you can quickly get values to look at a table, okay? I want to back something up because this is a preview for tomorrow. We're going to go right up to the bell, folks, today, okay? And since you're here, I'm going to kind of keep teaching you some stuff, okay? Look at this problem. We're trying to find the limit. As x approaches 2, x squared minus 4 over x minus 2, okay? We just saw on the table it equals 4, right? Right? Didn't we get that? Now, algebraically, if I put 2 in here, I got 0 over 0. That's that indeterminate form. We don't like that. What you're going to find tomorrow is if you play around and clean things up, watch what happens. Can't I factor the top and factor the bottom? Oh, the bottom's already factored. Do you remember doing this in pre-calc? And we're going to call this the offending term. Okay, we can cancel that out. That's what makes my denominator equal 0.
And then you get the dang 4 right there.
Then you plug the 2 in and you get the dang 4.
Oh, Shannon, that is so easy.
So, when you have an issue where you end up with 0 over 0, you have to play with the algebra a little bit to try to cancel out that offending term. At x equals 2, when you cancel it out, you get a hole in your graph. What happens, what if I had this, x plus 2, x minus 2, and I cancel everything out, but I end up with x plus 3? What happens at x equals negative 3? Does anybody know? When you can't cancel it out?
0 is...
Negative 3 makes my denominator equal 0. I can't cancel out my offending term. It's not a hole in your graph, it's a vertical asymptote. So if I did a limit here as x approaches negative 3 and I can't cancel it out, if I graph that at x equals negative 3, I have a vertical asymptote. If you have a vertical asymptote, that means your graph might be getting super, it could be doing something like this. Would there be a limit at x equals negative 3?
No.
D, N, Does not exist. Just write that if you don't have a limit. Okay? All right, I think there might be one more thing that I have to go over. You present. This, limits that don't exist. Okay, when you're graphing, we're talking about graphing tables and graphs. Tomorrow we're going to get into the algebra. I gave you a little sneak peek. Limits don't exist if f of x approaches a different number from the right and the left. You're following the roads, but they don't go to the same house, right?
Yep.
This is a DNE at x equals 3. F of x or increases or decreases without bound as x approaches your C value. That would be where you got an asymptote, right? Okay? So you could have a D and E here at x equals 0. Notice if I divide by 0, I get issues.
Yeah.
Can't have that. Something's funky going on in a graph. We got a hole or a vertical asymptote. These are oscillating functions. Sine of 1 over x, if you graph that, when it gets super close to 0, it just goes bing, 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 bing. If you're doing this and you're getting super close to 0, do you think you're actually approaching any specific number? So that's a DNE, an oscillating function. Limits don't exist if you're following the roads and they don't meet the same house. Limits don't exist if you have increasing or decreasing without bound at that x value, vertical asymptotes. And limits don't exist if you have oscillating functions. All right, so that pretty much takes us up to the bell. Tomorrow, you guys have to do a limit activity at home. Okay? I'm going to give you, in the folder, there's 2 things you got to print out. There's one limit activity, one where you're matching limits to graphs to statements. You cut them out like little sheets and match them all up in pairs. And then there's another worksheet that you have to do. Okay? So that's going to be part of homework, so that's expected. Okay? Your homework for the limit stuff won't be due for a while, but your pre-calc homework will be due next week when you turn in your test. Okay? It's usually a day after you turn in your test. Okay? The quiz, the factoring review, and that practice test.
So this isn't going to be on our pre-calc test?
No, this is new stuff. We got the pre-calc review test. It's just that stuff we did first week of school. The
Okay.
quiz, the stuff you did outside. You did the practice quiz, the practice test, and the factoring. This stuff is not on your test this week. Okay? All right. Are we good, folks?
Oh, we're pretty damn good.
Okay, so I'm glad